if there is a situation that is coming up, just let me know. I will excuse you for classwork participation that day, right? You just needed to let me know if like anything comes up. Just don't be that person that does what I just said, okay? All right, guys, what is the first? What do you guys think the question is your first answer is? I mean, what do you think the answer to the first question is? Not really an answer. Describe to me what you're seeing.
The electrons in the sphere repel from the electrons in the rod and move to the bottom.
Okay, the electrons from the sphere are repelled by the negatively charged rod. So the first thing that happens, right, is rod brought near sphere, electrons move down, are repelled and move down. Again, guys, I don't care if you're correct or not, right? The main thing is whether or not you're thinking. I don't care if your answers are correct or wrong. Rod brought near sphere. Electrons in the sphere are repelled and moved down. Then, so what happens after that? What do we notice about the overall charge of top and bottom after the first thing happens? After the electrons move down to the bottom, what is the overall charge of each section now?
The top is positively charged.
Yeah. So, guys, I'm splitting up the timelines here. This is right after the rod is brought near the sphere, but not touching. So the top part will be positive. The bottom part will be negative. Right? And so now the rod touches the sphere. So the rod touches a sphere now. What happens when the rod touches the sphere?
The electrons from the rod transfer to the sphere.
Yeah, so you see electrons transfer over. Why? Why are electrons transferring over? Someone other than Jonathan. Tell me why these electrons are transferring over. Something must be causing them to. Because it's metal means it can transfer, but that's not the main reason. It makes contact, that's why it's transferring over, but that's not, again, that's not the main reason. Yes, that's correct. People who message me privately. Anyone want to publicly say it, or are we just gonna be stuck here for like the rest of the day? Is that what's gonna happen? I know you guys don't care, but I do. I don't want to be stuck here for the rest of my day. Why are the electrons transferring over? Okay, good. Yes, because the top part is positively charged. The top part, there is a lack of electrons in the top part of the sphere. It's positively charged. Well, what's going to happen? This positively charged sphere will attract spell positive wrong again. The sphere will attract electrons because the top part is positively charged, right? There is an absence of electrons on the top. That was what I was looking for. That was the main thing I was looking for. You're correct also, Brendan. Again, like none of you are wrong, but none of you were right either. You weren't getting at the reason. You guys weren't wrong in the fact that what you guys said was were facts. But you guys weren't right in the fact that you didn't tell me why exactly the electrons were moving over. Sure, it's a metal, which means electrons can move, but that's not why the electrons moved in the first place. I'll give you guys like a minute, 30 seconds to a minute. Please don't finish the entire. Please don't finish the entire please don't finish the entire Go formative. You copy your own response. The hell? But why? Yeah, sure. I mean, this is gonna be marked like minus 10 points. You're not supposed to do number 8 yet. We're on question 1. We're on question 1. We're doing these questions together. All right, let's move on to question 2. Now, before we move on to question 2, I do want to talk about this though. We talked about this on Monday and Friday. So in metals, there are a sea of electrons. So these electrons can move wherever they want, right? Electrons are free to move wherever they want. They just don't because they're all repelling each other, which means they want to stay as far away from each other as possible, which is why they're evenly spread out. If it wasn't for the fact that electrons repel each other, they would go anywhere they want. Now, what you learned a few days ago, or Monday and Friday, is that you learned about electrostatic induction. You learned about electrostatic induction, which means, which is basically when you move a charged object near another one, but they don't touch. And that's called electrostatic induction, right? That's called induction. Electrostatic induction, right here, right here. What we're going to be talking about today, we're going to talk about conduction. We're talking about electrostatic conduction. All right, so it's conduction right here. When two objects touch, what happens to the charge when two objects touch? Oh my God, I forgot. I thought I forgot to start my recording, but I'm glad I did. So now this is an image of conduction, right? When you touch another object, if you were to touch a neutral object, you have electrons to transfer over. Now, that's you can easily see that. And on the other hand, on the opposite end of the spectrum, when a positively charged object comes into contact with a neutral object, electrons will transfer from the neutral object to the positive object. So this is the opposite now. So to put it this way, whichever side has the most electrons, those electrons will go to the side that has least electrons. And I will give you an analogy to this. I will give you a very good analogy. It's been used multiple times by other people. That's why it's the best, or rather, that's why I think it's good. So to make an analogy to that, let's say we have two full tanks of water. I'm sorry. Let's say we have two tanks of water. One is full, the other is half full. What happens? What happens if I connect the bridge?
Some
If
of
I
the
would-
water from the full tank will go to the half tank.
Okay, good. Yeah, the water from the full tank will go to the water with the half tank. What are the water levels going to be?
They're going to be equal.
They're going to be equal. Like the water levels will be equal. I feel like this is something intrinsically you guys are, just by the fact of growing up in this world, you know that to be true. It's like, it's not really something that needs to be taught to you. You guys intrinsically, just by the fact that you're living in this world, you know that that's what's going to happen. And what's going to happen to the water levels after you take away the bridge? Right? Let's say you remove this bridge now. You're going to remove that bridge. What happens?
The water level is going to be equal.
The water levels will be equal. And that's number 3. That's number 3. So what if you live in space? What kind of space station are you living in? Are you living in a space station that spins and can generate its own artificial gravity? Or are you talking about the space stations we have right now, like the International Space Station? Because if there's no gravity, then nothing will happen. Because the only reason why this happens is because there is gravity, right? There is gravity, so that's why this happens. Gravity is pulling the one that has more water down, and that's why they even out. Also, we're pretending that these tanks are open to the air, because if it wasn't open to the air, then nothing would happen because there's pressure here. There's air pressure if the tanks were closed, so nothing would happen. So we're pretending that they're open air tanks. Yeah, if there was any normal space station that we have right now, the water wouldn't go anywhere. Because they do this because of gravity. Then you'd have to face it. It really depends on your orientation. But I'm pretty sure nothing would happen. Nothing would happen. So I want you guys to apply that analogy now to charges. I want you to apply that same exact analogy with the water levels to electric charges now. And I want you to describe what you see here. Just as a reminder, can anyone tell me what E means? No, it doesn't mean electron. It doesn't mean electron. It doesn't. It means elementary charge. If it's negative 1e, sure. This means 1 electron because it's negative, but the E itself, E means elementary charge. E does not mean electron. You know it means electrons here because you see the negative sign, so you know it's negatively charged. But the E by itself means elementary charge. E by itself means elementary charge. So you have -4 elementary charges here, which means you have 4 electrons. So what are you guys seeing here? Describe to me. What do you guys see in number 4? Take your time to write it down too, by all means. They're trying to become equal, okay. I mean, that's basically it, right? I gave you that analogy for a reason. You want an equal amount of charge. You want the charges to be shared. So for you to get an equal amount of charge, well, 2 electrons must be transferred over. And here is something that students will have a misconception about. You are not trying to share an equal amount of electrons. You are trying to share the charge. You're trying to share the charge. You're not trying to share electrons. You're not talking about covalent bonds here, right? We're not talking about covalent bonds. We're talking about sharing charges. Now, let's move on to number 5. Number 5 is a little bit harder because I already know the misconception here. You guys think that you must have an equal amount of electrons being shared. And what this image shows you is proving that wrong. You do not need to have an equal amount of electrons to share a charge. So write down, take a minute to do number 5, guys. I want you to look at what number 5 is saying. What's 3 and 4? There really is an answer. You're just describing what you see. But what is 3? What is object number? Number 4 was electrons were being shared. I mean, not electrons, charges was being shared. So the electrons transfer over to circuit. And describing what you see, explain why. Like some of you writing like electrons transfer over, why are they transferring over? Because that's really important. Like knowing why something happens is equally important to like knowing what happens. Actually, I would say that's more important because knowing why something happens lets you think for yourself. So when you encounter an unknown situation, you at least have like some knowledge of how to go through like solving this unknown thing. All right, anyone want to take a stab at answering this question? Anyone? Non-equal amount of protons, protons don't, it doesn't matter whether or not protons are equal or not. They both have uneven amount of protons in the beginning anyway. I would say the charges balance out. Yeah, the charge is supposed to balance out. A transfer of electrons from a sphere of positive charge rod due to force of attraction. Yeah, you're not wrong. Person who messaged me privately last, whoever said a transfer of electrons from a sphere to a positively charged rod due to the force of attraction between protons and electrons. Yeah. So the goal here is when two objects touch, the goal is for the charge to balance. That's the analogy I was trying to make with the water, right? With the water tanks. You need to balance out the charges. Now, originally, this charged object had four protons. Let's say it has no electrons at all. And this object right here has 5 protons, and it has 5 electrons. Well, the protons, the positively charged object is going to attract electrons from the neutral object. And so 2 electrons transfer over. Now, then what happens after that is that there are 4 protons and 2 electrons. And here you have 5 protons now and 3 electrons. And in both cases, also answering all questions within a minute, like just now, also doesn't help your case. I didn't even move on to number 6, yet you're actually doing number 6 right now. Why are you still typing? So in both cases, you have 2 more protons than electrons. So the charge of both of these objects are the same. You have positive 2e. You have positive 2e. So in the end, your charges must be balanced. It's not the electrons that are being balanced, it's the charge. It doesn't matter how many electrons you have. That's insignificant. The only thing that matters is whether or not your charges are the same after contact. All right. Any questions about this? Please raise your hand before I move on. I'll give you like 30 seconds to a minute to finish writing your answer to number 5. Now, if you're done with question number 5, you may move on to question number 6. So go ahead and see if you have a response to number 6. All right, let's move on to number 6. Anyone have an answer to number 6? What do they think?
I say that the charge splits and keeps splitting along.
Okay.
So from the full mass of -6 times 10 to the -6c
Mhm.
power,
Coulombs.
it splits, and then to that it splits again to the third, and there was a fourth. It was split again.
Yeah. If there was a fourth that was also 0 coulombs, it would. If it was also neutral, then yeah, it would split. So what's the idea here is that you must share charge. Now these are very relatively simple charges, right? You're basically doing a charged object with a neutral object, and so that's relatively simple. It's relatively simple. Okay, but we are going to do 2 practice problems tomorrow that don't deal with simple charges. It's a little bit more difficult. But yeah, guys, make sure you submit the no, don't submit it. I'm sorry, don't submit it. Make sure you guys, if it is simple, then why is it harder? I mean, it's pretty simple. We can do this like really easily right now. Actually, no, it's.
Well,
I
you
don't want
said
to do it
submit
in
it?
3 minutes. Huh?
So submit the goal formative.
No, don't submit it. Don't
Okay.
submit it. Guys, we'll continue this tomorrow. And then we'll see you guys tomorrow. Have a good day.
Have a nice day.
Bye bye, guys.